Alright, in this video we're going to walk through a practice problem for parabolic motion. A parabola or parabolic motion is something that has both an up component, a down component, mixed with a horizontal component. Okay? It's something that was starting on the ground, went up in the air, and came back down in a non-vertical pattern. So things like that would be kicking a football or firing a cannon, something like that. The only additional trick or step, if you will, that you have to go through for parabolic motion beyond the horizontal projection problem is Sohcahtoa. Now I know some of you have never heard of Sohcahtoa or sine or cosine. You haven't gotten there yet, and some of you probably have. So this first part of the video is going to be a brief overview of what you need sine and cosine for parabolic motion in our class. It is not exhaustive, it is not complete, it is not anything you need to use specifically beyond what we are using in our class. Okay, what you guys do with it in math will probably be a lot more developed, but I'm just going to show you what you need to know to solve our problems. Okay, Sohcahtoa is a mnemonic device to help you remember sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and tangent, opposite, adjacent. Okay, now this we are not going to use for our purposes. We do not need to use TOA. We're just going to use Sohca. All right, now Sohcahtoa has to deal with right triangles, and we'll get some kind of angle, and we'll either have an hypotenuse, an opposite, or an adjacent. And in math class, those would just be numbers or distances. In physics class, these are going to be velocities. Okay, so these are always going to be measured again in meters per second. So these are velocities. In the problems that you'll have, it'll be something like a football was punted at 22 meters per second, blah, 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 blah. Okay, in the word problems, the velocities that we provide to you are going to always be the hypotenuse. And you're going to need to use sine and cosine to find the opposite velocity and the adjacent velocity. Okay, so for our purposes, opposite is going to be the velocity in an, let me erase that, will actually be the initial velocity in the y direction, and this is going to be the initial velocity in the x direction. Okay, so for if we wanted to use find the velocity in the y direction, we would use the opposite over hypotenuse, which would be sine. So this is the so part. Sine equals opposite over hypotenuse. This is the same thing as saying hypotenuse times sine of the angle equals opposite. And for adjacent velocity, or the x velocity, we would use cosine. Cosine is adjacent over hypotenuse. Okay? And again, can be written as hypotenuse times cosine of the angle equals adjacent. All right, so let's look at one. A cannonball is shot with a velocity of 34 meters per second at a 40-degree angle to the horizontal. If it hits the target at its maximum height, how far away is the target? Okay, so first things first, let's draw a little picture. Here's our cannon, and it's going to go on a parabolic flight back to the ground, and we wanted to know how far away is the target, and the target is set up to hit the maximum height. The angle that the cannon is at to the ground, horizontal, is 40 degrees, and we know that it was shot at a velocity of 34 meters per second. Remember, this velocity is always going to be the hypotenuse velocity. Okay, so the next step is to write our chart, because remember, you're dealing with x and y, vi, vf, acceleration, distance, and time. Time is going to be the same for both x and y direction. That's the same as horizontal projection. And just like horizontal projection, in the x column, we do not use final velocity or acceleration. Okay? To figure out the initial velocities for both x and y, we have to use Sohcahtoa, okay? And specifically the so and the ka part of Sohcahtoa, all right? So initial velocity in the x direction, again, this is going to be adjacent. This is going to be opposite. So to find velocity in the x direction, down here, I'm going to use adjacent. So that is cosine. And we can do hypotenuse times cosine equals adjacent. Or in our case, it would be 34 times cosine of 40 degrees equals adjacent. And that, do the math, so that's going to be cosine of 40 times 34 gives us 26.04 meters per second. Now, if you got a different number than 26.0455 on your calculator, you need to set your calculator to be in degrees to radians. Okay? Your calculator is not set up correctly. I am not going to give you instructions on how to set it up correctly, but it does need to be in degrees to radians to get that correct answer. So if you got a different number than 26, your calculator is not set up correctly. Try that now and search in your user manual of how to set it to degrees to radians. Okay? All right. Assuming you have your calculator set up, now let's find velocity in the y direction. Again, that's going to be opposite. So this is going to be sine, so opposite over hypotenuse. That can be rewritten as hypotenuse times sine equals opposite. So that is 34 times sine of 40 equals opposite. So 40, the sine of it, times 34 gives us 21.85, so we can round that to 21.9. Okay? So those are the numbers you should get, and those should be the only numbers that you get. If you got a different number, you need to set your calculator to degrees to radians. Acceleration, final velocity we don't know. Acceleration we do know, and that's going to be a negative 9.8. And it's negative 9.8 because it's going from the ground up, and we're stopping at maximum height. So if you really want it to, maximum height is going to be velocity at maximum height is 0. So final velocity is 0. We don't know the distance of it, and we want to find time. So we don't know distance and we don't know time, but we do have an initial velocity that we calculated. We know final velocity is 0 because at maximum height, final velocity is 0. And we have a negative 9.8 acceleration because we're going from the ground up against the force of gravity. So we can actually find time using acceleration equals final velocity minus initial velocity over time. That is going to end up looking like negative 9.8 is 0 minus 21.9 divided by time. Time is minus 21.9 divided by minus 9.8. And that is 9 divided by negative 9.8, 2.2 seconds. Plug that in here. I now want to find how far away is the target. That's our ultimate thing. And that is going to be the distance in the x direction. So again, we have velocity equals distance over time. Velocity in the x direction was 26. We want distance, and time is 2.2. So times 6. And that distance is going to be 58. It's going to be 57.2 meters. All right. Again, this math, we're just kind of layering, right? We start it with formulas. We then add charts in with horizontal motion. And now we've added Sohcahtoa. Okay? And you have to work backwards. You have to do Sohcahtoa first to get initial velocities for x and y. Fill out your chart. Choose the right formula. Plug in the math. Get your answer. Watch this video a few times if you're confused. Try all of the practice problems. And I will see you in class.